Hey everyone, welcome back to the channel. Today we are diving into an incredible data structure that's widely used in tech industry, Bloom filters. Ever wondered how Netflix avoid recommending shows you have already watched or email system filter spam? It's all thanks to this smart and efficient tool. Let's explore what a Bloom filter is, how it works, and where it's used in the real world. First, let's start answer the question of the what. What is a Bloom filter? A Bloom filter is a probabilistic data structure that allows you to quickly check whether an element might exist in a set. Unlike hash tables, Bloom filters are extremely space efficient and provide fast lookups. But there is a catch. They they allow false positives, meaning they might say an item is in the set when it isn't. However, if the filter says item is not in the set, you can be 100% sure it is absent. Okay, Bloom filters are perfect for scenarios where memory is limited and a tiny margin of error is acceptable. They use two key components, a bit array and hash functions. Okay, let's see a scenario how they work so we can understand. So let's make a quick example. Let's assume that we have our data. Okay, no. And our data. Okay, so this is our data. Our data, it will, and we have the other thing, we have what we call a bit array. And we will talk about all of them. And we have hash functions. Let's create them and let's after that start to understand what is going on. No, let's make it bigger. Hash function. Let's call it hash1. And make it smaller, please. No, make the size. Hash2 and hash3. Okay. So we have three hash functions, hash2 and hash3. And we have a bit array. Okay. Let's create the bit array. Grid. I want something like okay, this is what we looking for. So okay, the bit array it will be consist of 0 and 1s. Let's make the font quite bigger, and let's make this as greenish. So 0. Oh, okay. Let's make it middle and middle and middle, and the font size is bigger. Okay. Maybe 0. No, let's make it this one. 1 0 1, and let's make 0 and 0, and let's make it 1 because I'm trying to make at least 3 1s. Okay, let's change the 1 color so it will be easier for us to no. Okay. Okay, so let's look at this example, and let's just make it like that. And okay, so right now we have our data, we have our hash functions, and we have our bit array. we need to break down how Bloom filters works in 3 simple steps. First, we have initialization, inserts, and membership checks. So in the initialization, we start with a bit array. This is a bit array of size m, whereas all bits are initially set to 0. But right now we have 0 and we have 1, and we talk about why we have 1 in a bit. You also need k-independent hash functions. We have hash functions here that can map an input to a position in this bit array. Number 2, we have the insertion of an element. So when adding an element, we pass it through the key functions. So we have data. Let's assume we have a lot of different amount of data. Let's add another one here. Let's add another one here. Okay, so we pass this data to the hash functions, and each hash function outputs a position in the bit array. So for example, this one will position here. We basically will send it to all the ones. Let's say that it will send here, and this one will send here. Okay, and after that we set the bits at those positions to 1. This is how it works. To check if an element exists, we pass it through the same hash function. If all bits at the resulting position are set to 1, the element is probably in the set. If any bit is 0, the element is definitely not in the set. So imagine you are building a web crawler. You can use Bloom filters to keep track of visited URLs instead of storing all URLs in memory, which is costly. You add visited URLs to the filter. Before visiting any new URL, check the Bloom filter if the bits indicate probably in the set. You can skip it. This approach saves memory and keeps performance high. So Bloom filters are widely used across industries where space and speed are critical. So let's look up in some real-world applications. I would say first it's been used in web caching. It's been used in web caching a lot. Like web servers use Bloom filters to check if a resource in the cache is in the cache or not. If the filter says definitely not in the cache, the server skips a lookup and fetches the resource directly, saving time and resources. It's been used as well as spam filters in email systems. In the email systems. Email systems use Bloom filters to store hashes of spam email addresses. When a new email arrives, the filter checks if the sender might be a spam list, enabling a fast filtering. It's been used as well in the database. Distributed databases like Cassandra and HBase use Bloom filters to avoid unnecessary disk lookups. If the filter says a key doesn't exist, the database skips searching altogether, improving efficiency. We have also it's been used in the content recommendation. It's been used in content recommendation systems. Let's just make this quite smaller. No, not that smaller. Recommendation. Okay, so services like Netflix use Bloom filters to avoid recommending content you have already watched before suggesting a new show. The system quickly checks if you have consumed it. Number 5, also been used in the social network friend recommendations. Any recommendation like platforms like LinkedIn and Facebook ensures they don't suggest people you are already connected with. A Bloom filter helps by quickly checking your existing lists. So it's look like a Bloom filters. It's something is widely used in the real world. Okay, so the advantages, we said a space efficient, like ideal for large data set with limited memory, fast lookups, great for quickly membership checks. 3, we have simple and efficient, easy implement and maintain. The problem and limitations, first we have false positives because the filter may incorrectly say an element exists and it's not there. We have no deletions, like standard Bloom filters do not allow deletions. Variants like counting Bloom filters solve this, but the cost of memory is quite more. We have limited to membership queries. They don't store actual data, just membership information. We have hash collisions. As more elements are added, collisions increase, raising the false positive rate. So, that's it. There you have it. Bloom filters in action. They are a clever and efficient way to solve set membership problems without consuming massive amounts of memory. From caching to spam filtering, database to recommendations, Bloom filters are everywhere. If you found this video helpful, don't forget to like it, subscribe, and hit the notification bell so you'll never miss any video. And see you guys in future problems and future videos. We hope we have no problems.